Well, good evening and welcome to Maui Ocean Center's Sea Talk series. My name is Lily Solano and I am the Education Director here at the Maui Ocean Center. Just out of curiosity, by a show of hands, we have any first-timers here for our Sea Talks? Couple of hands, wonderful. Thank you guys so much for joining us today. Before I introduce our speaker for the evening, I'd like to go over the format for tonight. So the talk will go on from about 6 o'clock, so right now, to about 6:45 to 6:50 or so. And then that will be followed by 15 minutes of Q&A. So please do hold all of your questions until after. Our speaker for tonight has graciously offered to answer any other questions when we begin breaking down the room. So this evening, I have the pleasure of introducing our guest speaker, Dr. Craig Downs. Dr. Downs received his PhD from John A. Burns School of Medicine, University of Hawaii, Manoa. He is an expert in environmental forensics. He's been studying coral pathology and coral reef ecotoxicology since 1999 as a scientist with the U.S. National Oceanic and Atmospheric Administration. Currently, Dr. Downs is the executive director at the Hereticus Environmental Laboratory in Clifford, Virginia, a nonprofit scientific organization that is dedicated to conservation and restoration efforts of threatened environmental habitats. Tonight, he will be sharing about his recent studies on sunscreen chemical ingredients like oxybenzone and its impacts to coral reefs. So without further delay, please join me in providing a very warm welcome to Dr. Craig Downs.
Thank you. Thank you very much, Lily. I appreciate it. Is this too loud? No. Okay. My voice will probably go out halfway through this talk. Just let you know. So, and I also will try to speak quicker than I did 2 hours ago at Maui County Council. So, the big question is about oxybenzone and actinosate and sunscreen pollution is, why do we care? What's at risk? And what's at risk is a whole bunch of different things here in Hawaii. The tourism industry, the restaurant industry, the recreational industry, property values, tax revenue, cultural history identity. Is that better? Get away from that. There you go, feedback. What's the overall ecological problem? And this is the ecological problem. This was a very famous coral reef in the Florida Keys called Carey's Fort Reef. And I got to study it back in 1999 when I was working for US NOAA. And the legend goes is Jacques Cousteau put a brass pin at a very specific location back in 1975 so that somebody can come back and take a picture in a particular direction, a camera at a particular height every year. And this is what it looked like in 1975. Beautiful. 10 years later, 1985, it looks like garbage. 2004, it's a rubble field. 2014, it's desolate. There's nothing there. This is what Maui is going to look like, because the same complaints that the people in the Florida Keys said it'll never happen. We'll have great coral reefs for the rest of our lives for the next 200 years. 95% of Florida Keys coral reefs have disappeared in the last 50 years. 95%. Great little picture there. On the Big Island, nice Porites coral reef. This right here is Honolulu Bay in June when water temperatures are 26.8 degrees Celsius. So this is a non-bleaching temperature, but you have bleaching coral. And there was no sedimentation event in the last 6 months at this area before I took the picture. What causes coral bleaching? And why does it look like crap? I mean, that's a horrible looking reef. 40 years ago, Honolulu Bay didn't look like this. And so, I don't know if Darla's here, Russell's here, but DAR has been monitoring Maui's coral reefs since at least 1995. And they've been doing a really good job characterizing how the reefs are going. And for example, where's the laser? Is that the laser? Yeah. Honolulu Bay up here, from 1995 to 2005, it wasn't just decimated, it was devastated. Decimated is a loss of 10%. You have a loss of 80% of your reef, it's gone. Other places, not as great a drop, but you still see a decline. What's going on? Why do we see this continuous decline? This is my reef, Kapalua Bay, and this one right here was taken in 2008, 2011, 2014. If you've been to Kapalua Bay, you can't see anything. Its visibility on most days is what, 10 feet, 15 feet? And I remember a long time ago, 20 years ago, 30 years ago, you could see 100 feet, right? You can be, underwater near shore, and you can see the mouth of the bay because it's a really small bay. So what's going on here? The problem is twofold. On a healthy coral reef, you see a lot of recruitment and growth rates. So corals grow bigger, they reproduce, and this is a major driving force. You always have a death rate, but that death rate is much smaller than the recruitment and growth rate. But coral reefs in coastal areas around the world, it's not just here in Maui and other places in Hawaii, but in the Florida Keys, the Virgin Islands, what we're seeing is a really huge death rate and a very small rate of recruitment and growth. The death rate we can deal with. And I want to give you an analogy. A forest fire that goes through a forest, lots of devastation, a lot of dead trees, but it's an ecological necessity to maintain high levels of biological diversity. You get wildflowers coming in, you get faster growing trees, and you get this successional restoration back to the climax form for that community. We're not seeing that because there's no recruitment of any species into this area, except maybe algae. So as pathologists, what we're looking at are three major areas of why we're seeing this failure at the recruitment and reproduction. Developmental defects of juvenile coral, sea urchins, fish. Reproductive failure, meaning there's no production of sperm, there's no production of eggs. And another effect that really isn't talked about is called the Elie effect. And it's an ecological phenomenon. When a population gets so low, no matter what you do, it's going to collapse. It requires a certain intensity or tipping point or a certain density of the population to sustain itself. And once you lose 80% or 90% of your coral cover, you're not going to be able to come back. We can talk about this later, but there's a big effort, what's called active restoration. This is where people grow corals in mariculture cages offshore, they grow them in the laboratory. DLNR is doing that in, I think in Honolulu Harbor. And the idea is to plant coral in certain areas to help overcome this Elie effect. And that's the big reason why we should use and look at active restoration of growing corals and transplanting them. All that put together, you get a number of symptoms that coalesce into a single disease. And that disease is what we're calling coral reef zombies. And you see the coral, you see the fish, but in 10 years' time, they're gone. And they're gone because they're not recruiting, they're not reproducing, they're not coming back. At first, we discovered it was just with corals. And then we noticed it was with a whole bunch of other organisms, sea urchins, fish, seagrasses. I've heard reports from Singapore that they have entire fields of seagrass that are not flowering, and they're just dying back and they're not reproducing, and it's freaking them out because many of the sea turtles feed in the seagrasses, and that's impacting them. All the juvenile fish require the seagrass beds to survive. Once they go, those fish go. Some of these symptoms, are changed sex ratios, this allele effect where you have to have a certain number of individuals in an area to sustain itself, pheromones, especially with corals. If there's not enough individuals, they're not producing the pheromones, the corals just don't reproduce. So it's like going into a pickup bar and there's nobody at the bar. What are you going to do? Aborted juvenile development, and that's actually, I think, a big issue here on the west coast of Maui. And then behavioral changes in organisms, from fish to mammals to even corals. What drives many of these things are what's called endocrine disruptors. And these are chemicals that emulate or mimic hormones that naturally occur in us. But they come at us at the wrong time. So the best example of an endocrine disruptor are birth control pills. It's a semi-naturally occurring compound of progesterone and estrogen, and what it's trying to do is make you sterile. That's exactly what a lot of these chemicals do in the water, is that they make these organisms sterile. So I think it was back in 2004, folks on the Florida Keys were kind of freaking out. The coral reefs were dying, and there were lots of reports from NOAA scientists that they weren't recruiting. So we looked at what these corals were doing, whether or not they were producing eggs and sperm in this one coral species called elkhorn coral. So in that picture of Carey's Fort Reef, of all those big corals, those are all elkhorn corals. And this is just a snapshot of a single year in 2013. What NOAA discovered was that very few corals were reproducing. Very few corals had eggs in them, very few corals had spermaries in them. Watson Reef had nothing. And they were just counting, do they have eggs or sperm? They weren't even looking at were those eggs viable or not. And when, as pathologists, we looked at the eggs and sperm, and this is something I'm recommending for you guys to ask scientists from University of Hawaii or from DLNR to begin to look at. This is what the pink is kind of cool. So eggs are pink and sperm is purple. And this is what a healthy elkhorn reproductive porno picture looks like. Here's the eggs, here's the spermaries. This is what it looks like on Molasses Reef in the Florida Keys. The eggs are all messed up, but they're there. And the spermaries are all messed up, but they're there. None of these corals are going to create a next generation. And this happens year after year after year. And US NOAA has been looking at this since 2011, and there's no recruitment. They haven't seen any good sign of reproductive viability in these corals. It's just not corals, it's sea urchins. In the Caribbean, sea urchins are really important because they eat the algae, same thing as here. But a number of species of sea urchins have just kind of disappeared. One of them is the diadema. So a bunch of NGOs and US NOAA are trying to actively grow them and restore them. And there's a really famous aquarist by the name of Skip Martin Moe. He's literally the godfather. He wrote the Bible of how to keep a saltwater aquarium. So he was tasked to raise these sea urchins from little embryos to sexually reproducing adults. He was using piped-in water because he lives right in the Keys, and he was just using water from the bay. And the sea urchins would get to a certain stage of development, maybe 2 months old, and then they would stop developing and then die. And so he's calling me up and like, what's wrong? treat the water with activated carbon. So if there's any endocrine disruptors, or if there are any pollutants in there, it'll take it out and they should continue to grow. And that's exactly what happened, which is really, really good for an aquarium. But the entire Florida Keys is like this. 120 miles tract and it's all polluted, and that's why the urchins won't grow. And it's not just the urchins, it's queen conch, it's lobster. The Israelis have a certain problem. So this is the Gulf of Aqaba and the Red Sea. This is the Israeli side, this is the Jordanian side, this is Egypt, and this is Saudi Arabia. And the Israelis wanted to know, well, how much they were having problems with their sea urchins. And I said, well, let's look at sunscreens. Let's look at Oxybenzone. And here there was 5 parts per billion, which is really, really high. And what we call the party beach, it was 2 parts per million. But then you have like 300 naked Israelis out on the beach and they're all slathered up. Literally, they're naked. And they're out there, and every 2 hours they're full body sunscreen. And they don't put the white stuff on, the zinc oxide, because they want it to look clear and it's a party beach. And I mean, we trace it all the way into Egypt, the concentrations that were just high, and you could see this gradient of death. The water goes this way. And so on the Saudi side and on the Jordanian side, we couldn't detect any of them. And the sea urchins are great on this side. But on the Israeli side, not only were they looking terrible, there was a student who went out and looked at how many males and how many females were there. And he discovered that on the Israeli side, there were twice as many females than there were males, which is great for the males, but not so good for continuing the population. And so based on this, they're estimating that maybe in 20 years, there goes their sea urchin population in that area. So it's a localized extinction of a species. Again, a zombie. What's freaky is that oxybenzone does the same thing in humans, and a study just came out showing the same thing. So pregnant women who are exposed to lots of oxybenzone, they see the same type of secondary sex ratio shift. More females than males. That should really scare you. Not just because you have more females than males, but it skews the entire population. For me, it's kind of cool. Well, I guess for my son, it's kind of cool because he'll be surrounded by ladies. But you can't continue the population for 5-6 generations like this. So, zombie corals happens in everything I was talking about: sea urchins, fish, shrimp and crabs, seagrass. We're trying to get this into the public's mind, and that's why we came up with the word zombie, because it's an issue that affects not just us at at the water cooler, at the bar when we were talking about it. It actually impacts humans. Maui. The west coast of Maui is a mess. I'm sorry, there are places where I will not let my daughter go into. I let my daughter go into Kapalua. We took water samples 48 hours later. I was so mad at myself for not assaying the water samples before I let her in. You can get this study. This is the interim report, but NOAA has a final report. This is the report where we discover the highest levels of Staphylococcus bacteria anywhere in the world, ever measured. We couldn't count it, it was so much. It was in the tens of millions. Staphylococcus. When we take water samples from different places along the West Maui coast, and we take a sea urchin embryo, and we get the sea urchins from La Perouse, which was the cleanest place on this side of, on the west side of Maui, and we try to raise these sea urchin embryos into what are called plutei stage. So we let them grow in the water for 48 hours. None of them survived, even at Oluwalu. And that's where we were scratching our head on that one. It's like, what the heck's going on? It's not all sunscreen. So let me just, sunscreen is not the only factor. There are other factors. Sewage is probably the biggest problem. And then you have pesticide runoff, herbicide runoff, road runoff, termaticides. So when the termite company comes by and starts spraying around your house, you notice you have to put stones 8 inches to a foot from your house. You can't put plants around there. That pesticide is so soluble in water that basically that's why you have to twice a year spray your house with termites, the perimeter with termaticides, because it just washes out. There's nothing that's keeping that pesticide in and around your house. Where's it going? It's going right out in the ocean. So the warning that I'm trying to give to Hawaii is you're the next Florida Keys, but you're at this spot right here. And the problem is other people are noticing this. This was just published in the New York Times in the editorial section of the Sunday paper. And you do, if you go to TripAdvisor, we were just talking about this, where's the reefs? I mean, it's not like it was. And I come here once, twice a year with my family, and I get mad because Kapalua was not the way I remember it when I was a kid. So something's got to change, or this is what you're going to have right here. It's just going to be a wasteland. So we get on the sunscreens, and again, I want to put it out there. This is one factor of many factors, but it's one factor that we can all solve fairly easily. So sunscreen pollution, what is it? It's sunscreens. There are certain chemicals in sunscreens that we want to look at specifically. So when you look at the back of a sunscreen container, you'll see active ingredients and then inactive ingredients. On the active ingredients, this is a typical sunscreen, you'll see avobenzone, homosalate, octilisate, octocrylene, oxybenzone. But they're at really high concentrations. 34% of that bottle are these 5 chemicals. That's a lot. Why are we going over oxybenzone and actinisate? Well, oxybenzone and actinisate absorb UV light, both in the B range and the UVA range. Oxybenzone does it more in the UVA range, which is why companies like to use it, than actinisate. Actinisate is just pretty low. What I do want to show you right here is zinc oxide. Zinc oxide absorbs in the UVB, UVA. It's a broad spectrum UV absorber. And this is what we call the Jeff Bagshaw back of the envelope estimation. So this is a Hihi area. We know we have from 8:30 in the morning to 3:30 in the afternoon, at least 1,200 swimmers or visitors a day in this area. So the American Academy of Dermatology recommends that you put 32 grams of sunscreen on your body. I need about 90. Every 2 hours or every 90 minutes. And nobody kind of really just goes to the beach and swims for just 90 minutes. They go for 3 or 4 hours. So you need to apply at least 64 grams per person when you're out there. And if we assume just a 3% concentration of oxybenzone in the sunscreen, we're looking at 6 pounds of oxybenzone a day that goes right here in a Hihi. That comes out to basically 1,800 pounds of oxybenzone per year. And on the bottom, which you can't really see, the total amount of sunscreen just in this area is close to 60,000 pounds a year. I believe that, because if you look at what's brought in on a monthly basis of sunscreen and what's sold, this is one of the most lucrative places on the planet for sunscreen companies to sell sunscreen. Because everybody uses it. You got 26 million tourists coming in buying sunscreen almost every day. what are the actual concentrations in these areas? So here at the fish pond, the concentration of oxybenzone back in 2015 when we sampled here was 868 parts per trillion. And then in June of this year, it was 1,800 parts per trillion, right at this area right here. What do we care? Why do we care about these concentrations? The toxicity to corals and sea urchins is between 62 to 280 parts per trillion. If you've snorkeled here, you get in the water and you come out here and you're looking around here, there's nothing there, right? There's no coral. It's all dead. Where are the pencil urchins? They're gone. I know Steven Tyler takes a lot of drugs, but I can't think what he's doing there is going to have a huge impact in this Bay Area. No. And, you know, we look for signals of asphalt chemicals from the road into this area. It's not, we haven't detected it. So it's not asphalt, it's not petroleum product coming from the road. What's the major source? Everybody walking in. Actinosate is the other chemical we're looking at. And so in 2015, the concentration is 1,500 parts per trillion. In 2017, it went up to 5,000, basically 500 parts per trillion. Oh, sorry. The acute toxicity for corals and for sea urchins is 105 to 220 parts per trillion. Where everybody goes in now, because Jeff has a parking lot and he shuttles everybody in through here, the concentration is 10,000 parts per billion for parts per trillion for oxybenzone, 13,000 parts per trillion for actinosate. This is where everybody gets in. And when we were there, Jeff and I were standing there in June. He says, you want to sample over here? The corals were all bleaching. The temperature was about 27 degrees Celsius. It's not a bleaching temperature. You go over there, you look, the corals are pale. And these are Porites lobata and Porites lutea. Is that what you guys have here? Well, there wasn't that many compressa, the mounding ones. Lobata and lutea, I think it is. What are the concentrations around the island? La Perouse Bay is our control site. We didn't detect any there. And then you come over here to Ahihi and McKenna. You have threshold levels. I mean, these levels cause toxicity. Honolulu Bay, 1,900 parts per trillion. Actinosate, same thing. You have in the high hundreds of parts per trillion. Honolulu Bay, it's crapping out. I mean, it looks horrible. Over here where the surfers hang out, 1,600 parts per trillion. Where all the snorkelers hang out, 1,900 parts per trillion. This was in 2015. When you go to look out over here and you look at when the party boats come and drop off their clients, it's a great example of Sunscreen Sheen. You can just look in there and you see the sunscreen is a surfactant. So it's going to still the water and you can see it. Actinosate, so right out here on Black Rock, what's the concentration? Well, you kind of expect it's going to be high. 4,000 parts per trillion oxybenzone, about 300 parts per trillion actinosate. But how many hundreds of people do you have there per hour? A lot. Wahoo has its problems. So here's a great example of the Sunscreen Sheen. You know, people jumping in, sunscreen, the sheen begins to start, people getting back in the boat, there's the sunscreen sheen, there's the surfactant. But you can see it. I mean, we first discovered it in the Virgin Islands because a Rastafarian guy, we were looking at Trunk Bay, which is in the Virgin Islands National Park. It's all dead. And we're trying to figure out what's causing it. And the Rastafarian's like, Mon, you're stupid. Go around 4:30, 5 o'clock in the afternoon after all the tourists go away, right when the sun sets. The bay is beautiful because it's an oil spill. The water was just iridescent in color. I thought it was all the New Jerseyans spilling their beer in it, but it wasn't. It was sunscreen. So swimming is one source, sewage is the other source. 20 minutes after you put oxybenzone sunscreen product on your skin, we can detect it in your urine. So it gets in your body, you urinate it out, or residues on your skin when you take a shower. Comes off, goes into the sewage. The Spanish government was really worried about the amount of UV chemicals entering into their streams and rivers, and so they'll measure the amount of oxybenzone coming off from their sewage effluent. It's in the parts per thousand. So normal sewage wastewater treatment systems actually concentrate many of these chemicals and then discharge them out in the environment. I think we'll skip this part a little bit. So do you find it in coral? Yes, you can actually detect it in coral, and this is part of the forensic triangle. Sorry. When you do forensics, it's just like CSI. You have a triangle. There's one corner of the triangle is a dead body, that's the victim. Another corner is the smoking gun, and then in the third corner is a bullet. And it's the job of the forensic investigator is to get evidence to link all three corners of that triangle. So one of the corners of the triangle, or one of the edges of the triangle, is to show that oxybenzone, these chemicals, actually show up in coral or in different organisms. And so does coral accumulate does oxybenzone accumulate in coral? The answer is yes. And we were beat by the Chinese government because they did a study faster than us and showed that yes, these UV chemicals, especially oxybenzone, are accumulating in these corals at such high concentrations that their government went ahead and did what's called a risk assessment. And this is a formal procedure that forensic investigators will do to show whether or not, to show politicians whether or not there's a real threat to your natural resource. And their conclusion is yes, there is a real threat to their natural resource. And 20% of the coral samples that they collected contain oxybenzone concentrations exceeding the threshold values for causing larval deformities and mortality. So now the Chinese government is looking to how do we manage this? And they're leaning towards a ban. This is in fish. And so does oxybenzone accumulate in the muscle of fish? Right, BP3 is also called oxybenzone. Oxybenzone is also called BP3. And these are the breakdown of metabolite products. This is 20 parts per billion. 20 parts per billion oxybenzone and its metabolites are there in fish tissue. This yellow line points to actinosate. You're looking at close to 50 parts per billion. That's a danger to human health. Ever wonder what it is in your pokey? The Spanish, they'll be coming out with this paper at the end of December. These two species of birds also exist in Hawaii, and they're seeing declining populations of these birds. The eggs, when they check the nest, the eggs are not developing, so they're aborted eggs. And what they found was really high concentrations of oxybenzone in the eggs of these two bird species. The birds eat fish. The fish are loaded with oxybenzone that passes on to their eggs. So oxybenzone is both bioaccumulated and biomagnified through the food chain. 97% of the US population is contaminated with oxybenzone. It's in all of us, except for like the strongest hippies that live on top of the mountain. They don't use any type of product. Source of the contamination. This one was kind of fun. A lot of locals hate aerosol sunscreen. Tourists love to use them. I sit on Kapalua on the beach. I get there at 7 o'clock in the morning. The first tourists show up at 9. They always sit next to the big fat looking Hawaiian guy, because I don't know why, it looks safe or something. I know the best spots. And they get out and they spray themselves right next to me. And it just blows over. So we've all seen the aerosol spray. How far does it go? And it was the lifeguards in Makina Beach that actually helped demonstrate that you spray it here at the one lifeguard station, the guys down here can detect it 450 yards away. And that's a 10-second spray. And they accurately predicted what bottle and what brand was being sprayed, because they all smell different, right? Hawaiian Tropic smells a little bit different from. So when you're using a spray, or you get 150 people on this beach all spraying themselves, you're just covering this beach with sunscreen contaminants. Here's my bay, Kapalua. That's usually where I sit. And so we collected sand over here, and then we collected water here over a period of 3 days during tidal cycles. And what we found out was that about an hour or 2 hours after high tide, the highest concentrations of oxybenzone are seen in the water. You get all these people spraying on the beach, on the sand, the tide comes up. It liberates all those chemicals that are in the sand into the water column, and then the water comes out. And so every day you're going to see this pulse of sunscreen. It gets worse with the king tide, because the king tide goes right up to everything. So like the June or July king tide, the concentrations were off the chart. Is it found in the beach sand? Yes, we find high concentrations in the beach sand. So again, we're just kind of putting that forensic triangle together. What are the implications? I know there's not that many sea turtles that nest anymore in Hawaii, but anywhere there's a beach that there are nests are at risk of getting contaminated with sunscreen spray. Is it toxic to coral reefs? And here's what I want to show you. This is the NOAA bleaching alert. And at 28 degrees Celsius, sorry, I'm a scientist, so I think of Celsius. I don't think in Fahrenheit anymore. At 28 degrees Celsius, there's a bleaching warning, that corals might bleach. The problem is, in the laboratory, under optimal conditions, corals bleach at around 30 degrees Celsius, 30.3 degrees Celsius. So we've got a major discrepancy of 2 degrees Celsius here of corals bleaching. Corals shouldn't bleach at 28 degrees. Actually, in the laboratory, corals grow best at 28.5 degrees Celsius. We get the fastest growth rates. We get with bird's nest coral, we can't stop them from reproducing, and they just make a mess of the tanks. So this is the temperature that corals should be doing well at, but NOAA has it as this is the temperature at which corals are at threat from bleaching. Corals can bleach for a number of reasons, not just high and low temperature, but from calm sea conditions, freshwater dilution, sedimentation, parasite infections, and pollutants. So this is Hanauma Bay Preserve. If you guys have ever gone to Hanauma Bay, who really goes to Hanauma Bay anymore? This whole area here is dead, right? You've been there, it's dead. There's nothing there. What happened? Because this isn't stone. This isn't volcanic. This isn't lava. This is coral skeleton. So what happened to the coral? It's dead. Why don't we have babies coming back? Everybody remembers the big bleaching event of October 2015. In Hanauma Bay, corals bleached. And then when they came in January, in 2016, water temperatures went back down, and the corals quit bleaching. The temperature never got to 30 degrees in Hanauma Bay. And for about 2 weeks, it got a little bit above 29. Theoretically, none of the corals should bleach. But they all did, or most of them did. Why is that? Hanauma is awesome. The city pumps the sewage out of the bay. very smart, right? So the only real pollution factor that comes into the bay is either coming from the bay, outside of the bay, in there, or these 2,600 people that show up every day at 9 o'clock, except on Tuesdays. And that's when President Obama comes, right? So what's the average concentration of oxybenzone? Again, we're looking at about 10 to 12 pounds of oxybenzone per day going into this beach. That's basically 370 pounds a month. A little more than 2 tons a year. 150,000 pounds of sunscreen product per year goes in this bay. And it is. You walk in Hanauma and it's kind of like walking into a back alley massage parlor. It smells coconutty, it smells jasmine-y, it smells kind of gross, right? And that's because of all the fragrances and all the sunscreen product in the water. You can't even see a sunscreen sheen. It's nothing but milk. If you guys go in there about 3 o'clock, it's nothing but white milky turbidity, and that's not sand kicking up. Well, it is some sand kicking up. That's oils and product of your sunscreen products. There's a UH student, she did a small preliminary study, and she found that in Hanauma Bay, there's at least 1,500 parts per trillion oxybenzone. So it's pretty high. If her data is right, it explains why you see all this area being dead. It also explains why we would see corals bleach. So this is your Passalabra damicornis. This is your bird's nest coral that we find here in Hawaii. 14 days exposed to 500 parts per trillion, it bleaches. I'm not the only one doing this work. So the scientists at L'Oreal, cosmetic company, you guys all know what L'Oreal is, they wanted to know, am I full of pokey or is there something real there? So they replicated the experiment working with some scientists in Monaco in Europe, and they saw what we saw. Oxybenzone and another chemical they tested, avobenzone, caused coral bleaching. So this is an industry study supporting our work. A group in Singapore and Israel just published a paper showing benzophenone 3 is oxybenzone. They wanted to know what's the impact on algae, single-celled algae, both green algae and cyanobacteria. And what they saw was an impact as low as 10 parts per trillion. And they now regret not going lower down to the parts per quadrillion range because they think they would have seen an effect. This is for a short amount of time. This is 1 week. Oxybenzone is called a pseudo-persistent organopollutant. It's always there because people are always getting in the water and always polluting on a daily basis. So the concentrations are always getting refreshed and renewed. So this is just for a short amount of time. What happens if you're seeing it all year round? Or at least maybe 4 or 5 months during the high peak of tourism season. This study is incredibly important because it works at the production side of the food chain. This helps explain why we see corals bleach, because corals are both animal and algae. And the algae we know is very susceptible to this chemical. It affects the food chain. So all the critters that require algae to live, sea urchin planula, shrimp planula, fish larvae, you kill off the algae, they have no food source. What does it do to coral larvae, baby corals? This is what we're kind of famous for. We show that it damages their DNA at 129 parts per trillion. It causes bleaching in 8 hours. It's basically 700 parts per trillion. It is a really cool skeletal endocrine disruptor. So you see the white opaqueness around this deformed coral planula? Corals put down a coral skeleton, right? only when they're adults. This chemical, oxybenzone, acts as an estrogen mimetic. It acts like estrogen. What do we give postmenopausal women to keep their bones strong? Hormone replacement therapy, right? Estrogen, because your estrogen levels are going down. Come on, you guys. So what it's doing is it's causing the skeleton to inappropriately be put down around this coral planula. So it's encasing itself in its own skeletal coffin. The lowest observable effect that we saw with this species of coral, again, was 62 parts per trillion. And that's just because we didn't go lower. What does it do to fish eggs, fish embryos? This is Nemo, clownfish. This is what a 2-day normal-looking embryo looks like. There's the eye, there's the yolk, there's the tail. What's this? At lower concentrations, we suspected that, it was an endocrine disruptor. But what does it do to fish? So we had to go to Paris. Paris has this genetically modified fish. And it has a protein called choriogenin protein. This is an egg protein. This egg protein can only be produced in sexually mature females that are ready to undergo reproduction, that want to get pregnant, to produce eggs. The genetically modified part of this is that this protein is attached to what's called a green fluorescent protein. So when you shine a green light on it, it's going to glow in the dark, basically. So this will only glow in the dark, this area is its liver, if it's exposed to estrogen. And that's what this organism, this fish right here is exposed to, is birth control pill, and it lights up. Here's what a control is. It's dark. This is the liver of the same fish exposed to oxybenzone. And then this is the liver of fish exposed to benzophenone 1, the breakdown product in the liver of oxybenzone. So you're feminizing an embryo. You're causing it to produce egg protein. So we showed this to industry, and they kind of freaked out, because what are you going to do? This is hard data showing that it's an endocrine disruptor and it acts just like estrogen. So there are people out there claiming, probably not incorrectly, that every time you slap on the full amount of sunscreen lotion onto a 5 or 6 year old child, you're putting the equivalence of a birth control patch on that child. So estrogen soothes or calms the savage male, right? A study out of Taiwan showed that oxybenzone reduces the antagonistic behavior, the territorial behavior of males. It turns them into females. It makes them calm. Now this is really good, maybe if you're named Trump and you don't Twitter things out, but the problem is we want to keep the species going. And these territorial behaviors are necessary for the life history and the life cycle of these species. So this endocrine disrupting chemical is also a behavioral modifier. It gets even worse. So there's a process in many species of fish called sequential hermaphrodism. Tangs will do it, clownfish, wrasses, moray eels, gobies, parrotfish. And one way or another, either you have a dominant female or you have a dominant male. And for example, let's say if you have a dominant, you have a population of fish that are all, most of the population are males, whoever the dominant male is turns into a female. If you all turn into females because you're exposed to estrogen, does that population survive? No. The same thing, if you have a dominant male and a whole population of females, it will actually turn that dominant male back into a female. So this chemical, wherever it pollutes, all those fish populations in those areas are at risk of going extinct, turning into zombies because they can't get it on. They're gender confused. They don't understand what they're supposed to do. And that affects, we see that in the behavior. Other studies, this group came out of Cornell. He did this study because he went to the Big Island and he was really ticked off because he got in the water on the beach and it was all dead. And the further you got away from the tourists, the more life you saw. It was just easy to put it together. He's like, it's sunscreen. And so they did a study and they showed that this cnidarian is related to corals, but it doesn't put down a skeleton. It's called xenia. And these flatworms were significantly impacted by sunscreen when they were exposed to it in the laboratory. We took it one step further. This is xenia, and we're actually able to take really tiny pieces of coral or the xenia and get it to regenerate back into a polyp. And so this is what a normal xenia polyp begins to form after we cut it up within 8 days. At 250 parts per trillion oxybenzone, it doesn't differentiate. And the problem is that it stops stem cells becoming stem cells. It impacts development. Again, it's not our studies. These are the Italians showing that sunscreen impacts sea urchins. These were Spanish showing that it impacts bivalves, mussels and clams, shrimp, and macroalgae. It's not just the aquatic life. So this past year, I had over 140 high school students contact me, and they wanted to do their science fair project on sunscreen killing something. This one student emailed me and said, hey, my dad works for the PGA, and he's ticked because he helps manage a golf course in a southern state, and they're replacing the tee turf every 2 weeks. We send it out to plant pathologists at Mississippi State or Virginia Tech or Ohio State, and they can't figure out what's killing. Is it a fungus? It's not a fungus. It's not bacteria. What's killing it? Well, it's aerosol spray sunscreen. This is somebody spraying their feet, their ankles and their feet, and grass is living where your footprint is, but everything around it is dead. So this student did that project, and now the PGA's considering, what do we do about it? We'll skip this part. So in last year, we had a number of people, especially industry lobbyists, say, is there enough science? There's not enough science to show that it causes a problem. So I asked Senator Embryo to go to US NOAA and ask the same question. Is oxybenzone a threat to coral reefs? And it surprised me. He sent the letter in. 3 days later, it came from on high at headquarters at NOAA. This is a federal agency. And they responded to Senator Embryo basically saying, yeah, oxybenzone is bad. But near the end of the letter, what they also stated was, while additional research may incrementally add to our understanding of its impacts to additional coral reef species, additional research on the impacts of oxybenzone should not be a prerequisite to management action. This was basically US NOAA saying, there's enough science out there for any government agency to make a decision of whether or not to manage it. And it's not based on the science, it's based on political will. Part of the reason why I'm so tired, besides jet lag, is we had a great session at the Maui County Council, and what they're talking about here is whether or not it's a threat to Maui's coral reefs, and what do you do about it? You have to reduce it somehow. And it doesn't matter, well, it does matter, but it'd be great if you could restrict the ban of sales. It would be great if you could restrict use. It would also be great to do public education and multi-industry engagement. It's really funny because last year in the state legislative session, it would go through committee and you would have all these people write in. And one committee source was 180 letters that were saying, yes, ban the damn stuff. There were 6 letters that said don't. All 5 of those letters came from K Street on Washington, D.C., D.C. lobby groups. The 6th one was a Honolulu lobby group. So the only ones opposing it are the industry lobby groups. And in their letters, the same tactics that the tobacco industry used. It was almost verbatim, word for word. It's like, what? So consumer education and choice, and this is where I have to say mahalo to Maui Ocean Center. You guys learning about this is the start. Once you understand and know what the facts are, you can make a choice of whether or not you want to buy oxybenzone sunscreen or wear sun clothes or something like that. Formulation of eco-safer products. When I showed you the one chart of oxybenzone and actinosate, and there were 9 other chemicals, there are 17 FDA-approved chemicals to be used as sunscreens. Zinc oxide, titanium dioxide. There are other opportunities and options to formulate safer products. Sun clothes. We'll go to the next one here. Hold on a second. So sun clothes. This is my daughter. And yes, you're all sorry for her because she's my daughter and I make her wear this. And she looks like she looks like Peter O'Toole and but sun clothes make a difference. Here's a great example. Here's a woman in a bikini bottom and she's wearing a long sleeve top. This long sleeve top reduces her use of sunscreen by 50%. A 50% drop is a big deal. And if you're my daughter, you just get a little bit on the nose, a little bit on the cheeks, and there you go. It's possible, like this family here and this clothing company, that you wear these sunwear clothes, you can reduce your use of sunscreen pollution by 90%. We'll skip that one. Industry. There's a couple of people here who own sunscreen companies. In the last 2 years, sunscreen companies have actually risen to the challenge. ABC stores, they offer a wide selection of oxybenzone free, and they even label them, products in their store. Ocean Potion is known the world over for using the highest concentration of oxybenzone that you can put into a product. They shipped a huge shipment of oxybenzone-free and paraben-free sunscreen. It surprised the heck out of me. Some of you probably heard of like Stream to Sea, All Good. Most of these products use zinc oxide or titanium dioxide. Sorry, I'm starting to fade here. On sunscreen, UV chemicals. We'll skip that one because it really didn't relate to you guys. What shocked me the most about industry is they're tapped into what consumers are thinking. And a French company, this is the 2nd largest sunscreen cosmetic company in France, they came up with a commercial. And it was kind of stunning because they released the commercial 2 days before I gave a talk in Honolulu in June 2016. They already knew oxybenzone was going to be a problem, and they already knew that all their consumers cared about what the choices are. And so they capitalized upon that choice. How do I start this here? We'll start. This is the volume.
And diversity, patiently evolving for billions of years. We've only been here a tiny fraction of this time. And yet, we've already changed its face. When we move on, what will we leave behind? our concrete actions. That's what we'll leave. Our inscription will be etched into history and will serve as a path for future generations. Each one of us holds a small piece of the world's destiny in our hands. Each one of us, in our own way, can play a positive role in protecting what truly matters to our planet. Today, our concern reaches as deep beneath the surface of our oceans as it does the surface of your skin. Both of these environments are fragile. Both need to be preserved and strengthened. Deep below the sea, as sensitive as your skin, live the ocean's corals.
So when I teach this at a graduate level course, either at a law school or an environmental studies course, I ask my students, what do you take away from this lesson? And they're like, I felt it. They really care. The company cares. We got to fix the environment. I'm like, no. What you see here is a company scared to death that they're going to lose massive market share and be associated with anything that wipes out coral reefs. So industry, what this commercial tells you is that industry recognizes their product is a huge ecological problem. And they want you to think buying their product will overcome that ecological problem. What was this one about? Oh yeah, okay, so sorry. I've been up since 3. Industry interaction, thanks. This is one of the coolest things that's happening here in Hawaii. So if they don't do any type of legislative action, Hawaii has led the interaction of trying to reduce the use of Oxybenzone sunscreen products. At the Ironman World Championship, there's a number of boat companies that have teamed up with, for example, Hawaii Wildlife Fund. Snorkel Bob's is doing a thing with sunscreens and a couple of other dive companies. Aqua Aston has teamed up with a sunscreen company that gives to all their clients zinc oxide, so an oxybenzone-free sunscreen lotion. So the businesses here in Hawaii have actually informed and led the way to businesses in Florida and the Virgin Islands, well, what once was the Virgin Islands, and other places in the Caribbean, how they can reduce and mitigate sunscreen pollution. So I'm really sorry. I really thank you guys for all coming here. Thank you.